All right, friends, welcome. It is week 2, lecture 2. This is our fourth. And after this, we are halfway done with this stack from a lecture perspective. And after tomorrow, we're halfway done with this stack, which is crazy if you guys can believe it. We've already gotten halfway done. Next week is belt week, which is what? This always goes super duper fast, but they say time flies when you're having fun. Just a little bit, as always, I tell you this every single class where you got three. Sorry, I had a brain just meltdown right there. We have three core assignments due this week. It is loading, filtering data, Titanic, Project One, Part Two. As a reminder, we have moved this. It is now Friday. You had that one grace period of Sunday, but now it's tomorrow morning at 9 a.m. So make sure those are submitted. I will not grade all of them by the end of the day tomorrow. So if you're looking at 3 in the afternoon, you're like, why do I not have feedback? Because there's a lot of students, a lot of assignments. So I'll do my best. Um, but they are now officially submitted or due tomorrow at 9 a.m. So please reach out if there's any sort of external thing that's just abnormal. So as always, just a couple of resources for that I wanted to sort of give you guys is there's a making data tidy optional assignment. And with that, there's an awesome pandas cheat sheet. It is great. It is just a cheat sheet for all of these methods, everything that you can do, things that we haven't covered, things that we have covered. If you wanted to combine data sets, if you want to handle missing data, this is obviously just available to you. So if you did want to use this, you can use this on your exam, right? It's just a cheat sheet. Print it, put it up somewhere, frame it. I don't know, put it next to your wedding picture, right? It's going to be that important to make sure that you have just an understanding of this material. So that is available for you. Just wanted to point that out. That's also on this sheet. So if you are confused about what assignment, it's right there. Also, I want to point out here is our week 2 of what we're currently doing. There is a prep for belt exam. This is a sort of mid-stack piece that allows you to just sort of go through what are the belt exam policies, right? Here's some things to expect. You have 24 hours. We're going to really talk in depth on this next week. You have 24 hours from when you start your belt exam. You have 24 hours to submit it. It must be submitted by end of day in your time zone. I'm actually even just going to say 11:59 p.m. PST. So if you are on the East Coast, you got a little bit of a PDT, I guess technically now. You have a little bit of a benefit. You can stay up till 3 in the morning if you want, or I guess 2:59 in the morning. You must cite sources. Again, we're going to talk real in depth on this next week. But here's just a breakdown. And then lastly, there's this mock belt exam. Let me tell you this. Do this mock belt exam. If you don't do, well, you have to do your core assignments for sure. But if you don't do anything else, do this mock belt exam. It's really going to let you know what to expect for the belt exam. It's very, very similar to sort of the different things. Now, obviously, it's not going to I'm not going to give you the belt exam. It's not going to be a one-to-one thing, but this is very, very similar. So please go through this, do this. With that being said, next Wednesday, I am actually going to give, oh yeah, right here. I'm going to do a bonus lecture where I'm going to walk through this with students, where it's going to be more of like a team build, not just me building it, but we're going to get together. It's going to be from 5 to 6 p.m. PDT. And so if you guys can make it, awesome. Would love to have you join there. And again, it's going to be just a group going through this together. I'm not by any means just going to tell you every answer or else, doesn't help. But it's going to be very similar actually to today's class. We're going to start walking through some material together. I'm going to really lean on you guys to help us kind of discover some things as we talk about what we talked about on Tuesday and as we sort of implement new pieces there. So I wanted to make that available and just let you guys know that. And then as always, we at Coding Dojo love surveys. So there's another chapter survey right there for you, but that one is optional. Don't tell anybody. Okay. After this week's assignment, so after today and this week's assignments, you should know how to tackle part 1 of 2. So really for this mock belt exam, you're going to have to clean your data and then you're going to have to visualize it. So we're going to be able to do this part right here after today. And then this stuff, this univariate and multivariate visualizations, that's what we're going to learn next week. So that will be on your belt exam. I know that you only have to have weeks 1 and 2 core assignments, but week 3 material will be there. So please don't just skimp out and think, as long as I can clean really well, I'll be good. Nope. Unfortunately, there is going to be week 3 material. So make sure you are keeping up with your assignments there. And also, we talked a little bit about this in our office hour today, but as an encouragement, go ahead and start week 3 this weekend. That Friday date is going to creep up on you. So get in the habit of working a weekend ahead. You know, whenever you go to your next stack, you will, I'll unlock it, or it'll be unlocked on a Friday. So you always have the ability now to be a week ahead. So start working on next week's material starting on Saturday, because as always, obviously this week's material is due on Friday. So I guess you can technically start Friday. Any questions on sort of the belt exam prep, I guess, stuff? Yeah, pretty straightforward. Checks out. Okay. So here's some learning goals of today's class. We're going to identify types of data cleanliness issues to fix. I'm really going to hammer some generic things that we can fix. Again, things I'm really trying to set you up as best as I can for the belt exam. So we're going to hammer that. Find and remove irrelevant columns. So if we get data and maybe there's a column that doesn't make sense, we're going to find and remove that. We're going to find and remove and drop duplicated rows. And then we're going to find and correct badly formatted or incorrect data. There's a ton of different things that we're going to do in this idea of cleaning data. Cool. And I am going to step here because I'm going to do a code along where we're going to code together. But as always, if you guys are the type that likes slides, I do make them available for you to where you can walk through, and maybe I'll refer back to them. If we're really stumped as we do this code along, we're going to refer back. So I would encourage you guys to keep this open. And if I ask a question and you don't know the answer, odds are it's probably in this slide deck. So, you know, I added in again, the index locator and the general locator from last class, but odds are it's in here. So keep this open and use this as a tool. But if you do learn better by having slides, I wanted to make sure that you had those available. Before I get started, if you guys could in the chat, just sort of give me a heat pulse check of how you're doing in the cohort. How are you feeling from a 0 being I'm overwhelmed, I hate this, to a 5 of this is easy and I'm crushing that. If you guys could just do that for me in the chat, that would be awesome. Okay, some 3s, some 4s. Lots of 4s, lots of 3s. Again, I ask you guys to do this, not for the reason to sort of, well, A, I want to get a pulse check, see how you guys are feeling, but B, also to help you guys realize that, you know, if you are at a 3 or a 2 or a 4 and you think, oh man, everybody else is at a 5, we're really good at sort of creating that narrative in our head that everybody else is just getting it and it's on me. And so I like to do this typically every week, just to show you guys like, hey, everybody, you know, everybody's feeling that way. I don't think a single person put a 5. So, you know, if you are feeling like you're a 2 or a 3 or 4, like that's okay. That's where everybody else is at. You're not alone. And that, so I like to do that sort of little pulse check there. All right. So I'm going to reconnect this, which means I'm going to do a couple things. So today we're going to talk about data cleaning. This is available for, if you guys want to follow along, it's available right here on this collab. I don't know that I showed you this, but if you guys do want to follow along because you can't edit this, I believe I did. You say file and you say save copy in Drive, and this will actually save a copy. So it'll make a copy and then you can actually edit it. So it's just like a launch pad. So I thought I talked about that, but if I did not, you just say file, save a copy in Drive, and then you can actually edit it and follow along there. Okay, first thing I got to do is we're talking about cleaning our data. And why is that important? Well, because garbage in equals garbage out. no matter what we do, no matter if it is, oh, that's not what I wanted, garbage in and garbage out. If we have bad data, data that is not clean, data that is, um, garbage, no matter how good our algorithm is, no matter how fancy or sophisticated our machine learning model is, we're not going to get as good of a result as we would if we just had quality, clean data. So we want to make sure that this is something we really put a lot of effort in. This is not something that we sort of just stroll over, but something that we continue to try to almost perfect, if you will. That way, when we do learn those awesome machine learning algorithms and models, we have that part figured out and we can really be efficient and really, um, come up with some awesome, awesome answers. So it's really, really important. Also, when we're dealing with like missing values, if we're dealing with machine learning, it can't do anything with missing values. So you have to take care of those in order for you to do any sort of machine learning. So we want to make sure this is a really foundational piece for us to learn and start to understand. So let's dive in. First, I'm going to mount my drive. I've already got some of this stuff set up for you. I'm going to be using a data set today from Super Bowls. This is not super relevant. I didn't update it or anything from the last Super Bowl. Also because the Rams are in the same conference as the Seahawks. So like, LOL, who cares, right? But if you did want to mess with the data and you want to put that in your drive, you can put that here. If you click this little guy, it's going to take you to the data, save it to your drive, mount it, you're good to go. I'm going to import our libraries. Just get in the habit of importing these two guys. We're going to add in two more next week, but importing pandas, importing NumPy, get in the habit of doing that. You guys will, I mean, those are things you're always going to carry with you. Josh and Adam can attest there. Cool. I created my variable called file path. That is just the file path to my Super Bowl data. This is my Super Bowl dirty. Now I named it. So if yours is just called Super Bowl, it's because I wanted to hit on a couple things today. So I went in and, kind of changed my data. So that way I could really dive in and hammer some points home. And then I just do my PD read CSV. And let's first start by looking at my data. Okay. So see if I run sb.head, this is just going to give me a really general first look at my data. If I'm just looking at this from the beginning, what are some things that you guys recognize? Maybe some things that I need to change or some things that are maybe not necessary. Unnamed. Yeah. So this column right here. That's a great point, Brian. What else? What's some other things? If I'm looking at this data, what are some other things that maybe could be an issue that I'm going to have to deal with?
A lot of and I believe. So because I see a lot of and values under the referee umpire, like pretty much the repping staff names.
Yeah. Yeah. So it looks like for these first pieces, I have a lot of missing values. What's the code I could run if I just wanted to get, 5 random values? What would I run? Do you guys remember? I called my data frame SB, by the way. What would I run if I wanted 5 random samples? Oh, I said it, but Brian got it before I said it. So if I SD that sample, if I just say sample, then what's going to happen? It's only going to give me 1, right? So if I say 5, then it's going to give me 5 random pieces. So I can see, all right, so this 0 does match this guy, but it's not all of the data values or not all of the rows, sorry, that have this missing value. So, okay, I'm going to have to deal with that. I understand I'm going to have to deal with this unnamed 0. Sometimes especially when we download or when we open a data set in pandas, sometimes we do get this unnamed 0. There's 2 things we can do. We're going to actually end up dropping that column, but if you just for a bit or just at the beginning recognize this, you can just say index and reset my index to 0. And if I do that, or index call, sorry, it's not index call of 0. If I do that, now if I run this guy, it just switches my index to that first column. Right? So that's saying that unnamed 0. Now that's where my index is. So when I do SB head, that's it. So I'm actually going to take that out because we're going to handle that missing value. And I want to be able to visually see that. Okay, so we're off to a pretty good start. We have identified a column that we're going to go ahead and delete. And we've identified that there are some missing values. Before we do that, I just want to have a little bit of a recap for of what we talked about on Tuesday. We talked about filtering, we talked about loc, and if I wanted to filter out certain data, I want to create a filter that's going to be a big piece with your Titanic assignment. Can anybody tell me here? I've got a question, remembering that filtering is a process of selecting data based on particular criteria. We can have, whether it equals something or it's greater than something. We want to focus on the subset of our data. That's when that's a great usage of filter. And when you filter, you can use a Boolean expression to filter rows by the value in a column. So in your Titanic assignment, for instance, we have survivor and not survived. If I wanted all the survivors, it's a great time to make a filter. So that way I can get all of the, rows where that piece is true, right? So yes, David, you're way ahead of me. I like it though. Okay, so if I wanted to get all the rows where the state, so if I'm looking at this, I got coach winner, winning points, I got state. If I want to get all the rows where the state is California, and I want to create a filter for that, what would I do?
I'll probably just do the state column and then just do value counts, I think.
So I just want specifically the rows where the state
Right.
is California.
Oh,
I'm gonna call
then
this
you just,
Kelly. I'm gonna call this Kelly filter. Go ahead.
yeah, so basically you just create a filter. So you create a filter where basically the value in the state column is equal to California.
Yeah, exactly. So I'm going to say, okay, SB of state, that's identifying the column. And then I want to say where it equals, and then because this is an object, and we're going to get to that in a bit, but it's a string, right? California is a string. So I'm going to say California. Doing this in honor of Josh, who's here today to help and just sort of observe. He's in California. Cool. So great. I did that. I ran it. No issues. Let's go ahead and see what that looks like. So if I say Cali filter dot head, I cannot type when you guys are watching. Okay. Now, the reason I did that is to show that it gives us this Boolean expression, right? Or this first one, it shows that it's true. Right there. That's number 0. If I did up here, 0. And then it is false with the other one. So if I wanted to get all of the values that had California, right? I just want the rows that where this condition is true. What could I do? What if I said something like sb.loc, where I pass in my Cali filter. And then if I want all my columns, what am I going to put? Colon. Yeah. So let's see what happens if I do that. Okay. So now this returns all of the rows within my data frame of SB where that condition was true, where the state is California. What if I wanted it to all the states other than California? What's the little trick I could do?
You use pretty much the tilde symbol.
So what is it? I'm sorry.
Tilde.
Yeah.
Little snake symbol.
Yeah, the little squiggly guy, right? The little mustache. It's like a fancy mustache, I would say. If I do that guy, then it's going to give me every single state or every single row where that condition is not true, right? Just the opposite of whatever our condition was. Cool. Great job, guys. Cool. If I wanted to get the names of the coaches whose team won in California, what's a way I could do that? Something like that.
You could do a double filter, or you could just make the filter that you made a data frame and then get the index of it. I think.
Yeah. Why don't you walk me through that? Let's walk through that. I like that.
Which one?
Whichever, let's do the first one.
So you could make a filter just like you made above for California. You could, oh, I'm sorry, get the name of the head coaches who won in California. So I would just make the top one a data frame, and then I'd get index at the head coaches. I don't know how to
Okay.
explain
Walk
that.
me through the code here. What would you type?
One moment. Sorry, I'm trying to find where I have it written.
No, all good. All good. That's the idea behind today, is just sort of a code along so that way you guys can get your hands dirty.
Mm. Oh, well, okay, I'd go back. So first I do like, I don't know, California Super Bowl equals data frame of the filter above.
Equals SB of the filter.
No, so just like, yeah, or data, yeah, SB of the filter. Exactly.
Okay.
I forgot you put SB instead of filter.
Okay. Then what?
And then I would do.
If that even runs. Yep. Okay. Let's actually just explore what just happened.
Does that work?
Okay. So that
So it's
got me
thinking.
all of those. Yeah.
Yeah.
Now, what else could I do?
And then couldn't you just index at that? So like in square brackets, put
Where?
coach winner or whatever.
Where at? Right here?
No, at the bot. Well, yeah, I guess. You could just do it for the variable Cali SB, couldn't you?
Yeah. So I could say coach.
Yeah.
Winner. Okay. So let's see. Yep.
Yeah.
Perfect. So that is absolutely a way to go there. Good job. That's absolutely a way that I could have gotten the names of the head coaches whose team won in California. Way to go. That's awesome. Another way I could have done it is just said something like, I'm going to call this Cali 2. Because I know I'm dealing with a filter of all my rows where this condition is true, and I want to specify the specific column, I could say something like sb.loc, where I pass in my Cali filter, comma, and now I specifically just want the coach winner. And let's run that. Cool. And then if I say Cali 2 dot value counts, that is going to get me all of the value counts and all of the names, because see how some of these are duplicates. If I just do a value count, now Bill Parcells is not 4 times. It just shows it that there's 4 values of Bill Parcells. Both are acceptable. Both are ways to do it. So way to go. Cool. Awesome. Does that make sense? Any questions on that? Okay. So when we're cleaning our data, one thing we have to be aware of is irrelevant data. So data that doesn't matter. And that's information unnecessary or unrelated to our task, right? When we first saw this data, we saw this unnamed 0, right? And even Brian had pointed out that unnamed 0 is not necessary. It doesn't have anything to do, right, with what we're doing. So I can actually drop that. But one thing to know is we need to be absolutely sure that it's irrelevant, right? We don't want to just drop a bunch of data or drop columns. We want to keep data. Data is precious. We want to keep it as much as we can. So we want to make sure that we are absolutely sure before we drop data. In this case, it doesn't, that unnamed 0 doesn't tell us anything, so we can drop it. Another one would be, let's say we're creating a machine learning model that is like Kelley Blue Book. If you guys are familiar with that, where it can predict car prices. Or you might get a bunch of information from a car, from a user who signed on to go to kellybluebook.com. A column that might not make any difference is the user's name, right? If we are predicting, if we're using our prediction model to predict the price of the car, unless that person is like Oprah or Dwayne Johnson, it's probably not going to affect the price of the car. And so just really looking at our data and what our end goal is going to be really crucial. And when in doubt, there will be you can consult a subject matter expert. That is somebody who knows this data, knows what it represents, and knows what, sort of the end goal there. So when in doubt, you can consult them as well. We don't want to just go drop a ton of data for no reason. Okay. So the question is, what column seems unnecessary in order to drop it? So we decided that it is our unnamed 0. So what I can do is I can just say sb.drop. I'm going to pass in the columns. It's not that, columns. And I need to then pass in the name of unnamed 0. Okay. Now there's two things I could do. I could say SB equals, and this is redefining my data frame, right? It's redefining SB to now drop that value. But there's another way I could do it. Does anybody know what it is?
Delete.
Not delete. Well, yeah, you could delete, but if instead of having to redefine my data frame specifically, what I could do is
In place.
actually within this say, yeah, exactly. Say in place equals true. What that will mean is I don't have to redefine, right? This will redefine my Super Bowl or SB data frame for me. If I didn't do this, if I didn't do in place and I run this, it's going to not give you an error, but it's going to keep that column, right? Because I'm not redefining that value. But if I say comma in place equals true, that is saying, okay, go ahead and drop that column.
Unnamed needs 2 N's.
You
There
misspelled
it is. Thank
column?
you.
Oh, sorry.
Yeah, I'm just, I don't know how to spell today. Okay. Thanks, guys. Perfect. So now if I say sb.head, cool. You can see that it dropped that column. Any questions on dropping that column? The in place equals true versus the other one. The one thing I will say is you don't ever want to do both. You don't want to say SB equals SB.drop colons unnamed in place equals true, right? It's one or the other. And I don't know, Josh, if you or Adam have any preference. I like in place just because it's, I don't know, looks cool.
I
But
think in place, it doesn't really matter so much with the data sets we're using in this program, but it's a little more memory efficient because it's not making a copy or a view. So there's at no point are there two versions of the data set in memory. Whereas if you do it the other way, I believe that at some point in the process, there's two different versions of it before the Python garbage collection gets rid of it. And sometimes you're working with data sets where only one version of it will fit in your working memory because it's so big. On the other hand, when I'm working, especially with smaller data sets like this, I often want to keep different versions of the data because maybe I want one version with this dropped and one version that still has it. And so then that's what the other notation really helps with. And it can also make it a little more clear what's happening, how the data frame is changing. I think it's a little more readable, but it's really, as long as you're consistent, right? Because you want to train whoever's reading your code to recognize where you're making changes. So to see if they're using in place or whether you're redefining or changing the pointer. But yeah, just be consistent.
absolutely. Absolutely. Thanks, Josh. If you guys don't know, Josh is another instructor. So he's here just to hang out with us because he's awesome.
He's just a
and wants
smart
to.
student.
Just a smart, super smart student with a coding dojo background.
Always a student, lifelong
Always.
student.
Cool. Man, I really couldn't spell today. All right. So we've dealt with this irrelevant data, right? This irrelevant column. Now, one of the big things, and you will be tested on this, cough, cough, is you're going to have to deal with duplicated data. So one thing we can do is let's just check, right? This is a great thing to do, especially from the beginning, is check for duplicated data. So I can say SB dot duplicated. DUPLICATED dot sum. It's called a chaining method where we've got multiple methods attached to one another. But if I say this, I look and I can say, okay, I've got 3 duplicated rows. Great. So if I want to view the rows that are the duplicates, right? First, I want to check and say, okay, duplicated says that there's 3. Let's go ahead and look at them. If I do this and I say SB of SB.duplicated, what this is going to do is this is going to give me 3 rows. 2, 3. This shouldn't have given me 3. It should have given me 2, actually. Oh, I guess there's 4. I guess I added 4. Sorry. So let's walk through what just happened. So if I say this SB, so I'm going into my data frame and I'm just filtering out, I'm wanting to get the ones that are duplicated, right? If I just run it this way, it is going to assume the first row that it sees is the base row. And then it's going to give me all the other rows that are duplicates, right? If I want all of them, let's say I want to see all of the rows, including that first one. If I say keep equals false, what that will do is it'll give me every row. So not just this first one, this 10, or not just these 3, but it'll also give me this 10 that it was sort of assigning as the original first row. Any questions on this keep false piece? Does that make sense? You just
Why
put a
is
1
this?
in the chat. Go ahead.
Oh, now I'm confused because you did a sum and it came out to be 3 rows. And then you did this check here and you have 4 total rows.
See if this-
So
let's see if
I'm
this changes it.
seeing that the first row, they're not counting that because that's not the duplicated row. There's 3 duplicates of that row.
Got it. Okay,
Mhm.
thank you.
Yeah. So you see, if you notice, if I did this keep false, meaning I want you to give me every duplicate, now that number changes to 4.
Okay, thanks.
Yeah. So if I don't, by default, it's going to keep the first one and it's not going to count that and saying there's 3 additional duplicates of that first row, which in this case was row 10. Because if I run this without keep false, you see that 10 disappears.
Yes, thank you.
Yeah. Any questions? Does that make sense? Oops. Can you just put a 1 in the chat if that makes sense? Duplicates. I'm just telling you now, there will be a question, or part of the criteria is, did you check for duplicates? So I'm telling you, do that. Okay. And when we do that, we want to make sure that we walk through and just sort of eye glance it. Are these duplicates? Yep, they are. Looks like they are the exact same thing. John Elway, Bill Parcells, Phil Sims. Okay. So I've decided I don't need these values, right? They are exactly the same. One thing I will note is before it's not a bad idea to actually run this duplicated before we start dropping rows or dropping columns, sorry, like irrelevant data. So let's say that and this is a great example in this guy right here, is here I've got duplicate data, right? Where I've got height 70, age 31, some phone number, 72, 45, whatever. I have these 2 duplicates right here. But let's say I'm looking at this and I'm saying, well, phone number is sort of irrelevant. It doesn't really tell me anything. Now with cell phones, I mean, like my cell phone area code is still from New Mexico. I haven't lived there forever. Like it doesn't really tell you any sort of data. So it might make sense for you to drop it. But if you drop that, then what can happen is I don't have any sort of identifier to tell if this, or if these are actually duplicates, right? If, it's totally feasible for 2 people of the age of 45 to be the same height, right? For them to also have the same phone number that's more, that tells me it's a duplicate, right? And so when we are dealing with irrelevant data and duplicates, we do want to be aware of, is something going to be sort of like a unique identifier before we drop that? We might want to deal with our duplicates and make sure these are absolutely duplicates before dropping that column. Does that make sense? So like in this example, if I had already dropped phone number and then I ran duplicates, I have no idea if these are actually duplicates or not, because this is totally feasible, but they actually, are duplicated data. Does that make sense? Any questions on that? Cool. Easy peasy. All right. Cool. So I've identified my duplicated data. Now let's go ahead and drop our duplicates. Anybody know how we can drop duplicates?
Drop duplicated.
There you go. Yeah, it's drop duplicates right there. And then again, I'm going to say in place equals true. Or I could
I
have
would
said
love-
SB equals. Go ahead.
I just want to point out, when I am grading belt exams, this is probably the most common place for people to lose points, is because they forget to put the in place equals true when they drop duplicates. I cannot tell you how many belt exams and that lose points just because of that one little piece of code they forget. So they think they dropped the duplicates and they don't actually. So make sure you're actually getting them out of there.
Yeah, good point out, Josh. Cool. So let's run that. No errors, tells us we're good. Now let's go ahead and assure. So let's say sb.duplicated. .sum. Just to see, should give us a 0, and it does, which means we dealt with our duplicates. Any questions on dealing with duplicated data? This is a part of the exam. Next week, I'll show you, there's no secrets. I'll show you the criteria of what I'm going to grade you. And one of them is, did you check for duplicated data, and did you handle it? So any questions on this before we jump on to the next one? Okay. Now, the next thing is we need to deal with our data types, and we need to make sure that our data is all, they're all the correct data types. Cough, 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 cough. If I'm looking at this, you will receive something of like this you'll receive a data dictionary for your belt exam, where you've got your column name, you've got your data type of what it's supposed to be, and you've got a description of it. So what we want to do is when we have our exam, or when we get a data dictionary in a real world sense, is I want to make sure that my data matches what it's supposed to be. So if I go and look at this, let's first see what is it? Okay. Looks like I've got some integers and lots of objects. Is there any one on here that you might think, I'm going to go ahead and say sb.head, that you might think might be wrong? If I'm looking at this, I'm saying, okay, date, that's fine. SB, that's fine. Attendance, that makes sense to be an integer. QB winner, okay. Go ahead.
Point difference.
Point difference, exactly. So that doesn't make sense, right? Especially if I look at point difference, looks like some numbers. So what I would do is I would then run and say, okay, what is going on there? I'm going to say SB of point difference. I'm going to say .value counts. Because if it says that it's an object, right? And we think it's supposed to be an integer, that's often a good sign that somebody actually typed in a number, right? Instead of actually putting, the number 3, they typed in 3. So if I do this, I run this guy, look, I see a bunch. Somebody typed in the number 1, right? So what value counts does is obviously, or what it does is it goes through that and goes through that column and tells you how many times this value occurs in that column. So here it looks like there is a value of 1 that occurs 1 time. And because that happened, it changes my entire column to an object because it is a string. So I have to go in, I have to deal with that. Okay. What is, if I wanted to look and see sort of like, let's go look at that exact row. I could say SB of SB point difference equals 1. Okay, let's see what this gives me. And this now allows me to look at the row where that condition is true. And I see that, yep, looks like there just is an issue with point difference where it looks like it's supposed to be a 1, but instead is a, it was typed out 1. The same thing could be true and may even requires some sort of discovery basically of the row. What if it said, something of like 5 with an exclamation point, right? I would look and I'd say, okay, is that supposed to be 51? Is that supposed to be 5? What is that supposed to do? And I could look at this and say, okay, well, winning points was 20. So having a 51 point differential on this team that won had 20 points, well, that doesn't make sense, right? And so I would look at that and say, that must be a 5. And so by looking at that, we're going to have to sort of discover and utilize this row to make a decision on what we decide this value should be changed to. Now, this one's pretty easy because it's just, we think it's a 1. No big deal there, but just be aware that people have all kinds of things. If it's, a 4 with a dollar sign, is that supposed to be 44? Is that supposed to be 45? If it's dealing with age, sort of looking at that information is really, really important. So now that I've identified that, I want to go ahead and I want to replace that data with the actual number 1, because that's what it's supposed to be, right? We've assumed that it's supposed to be 1 point. Does anybody know how I would go and replace that data?
With replace.
Yeah, exactly. So I'm going to go into SP point difference. I'm going to see that is equal to, right? I'm now changing that value or that column. Point difference dot replace. Now this dot replace takes in 2 arguments. It first takes in what do you want to replace? So in this case is 1, separated by a comma. And then it says, what do you want to replace that with? And so I say a 1. So if I check that, all is good. If I see this guy where I say SB point difference dot value counts. I don't know why it keeps adding that extra one. Value counts. Let's spell the value correctly. That would help. Okay. So now I see that the 1 is there. But if I say sb.info and I look at my column, point difference is still an object. That's because when we change this, we change it to our value of 1. But now I have to typecast this column to the correct type. So what I can do to typecast, so typecast column to int, is I'm going to say SB of point difference equals SB point difference dot as type. And then I'm going to pass an int because I want this to be an integer. So I am now changing the value of this, or the type of this guy, to an integer. Now, this won't work if you still got a string in there. So you got to make sure you address all the values. But now if I do this, cool. And if I rerun this, now we can see point difference is an int. Makes sense? Any questions on that? Sorry.
I have a question.
Yeah, hit me with it.
I hope it's okay. So sometimes you'll have this problem where instead of an integer, it's a float. And instead of 54 rows, you have 40,000 rows. So a value, so there might be 30,000 different unique values, and one of them is wrong. How would you find that if your value counts is going to be too long a list to be able to find it?
Utilizing in unique. Is that what you're trying to get at there, Josh?
No, and unique, if you have 30,000 unique values and one of them is wrong. No,
What do you think?
what you could do actually is just try to typecast it. And pandas in the error, so the pandas in the error will tell you the first time it finds one that it can't convert. And then it's a little hacky, but you could just kind of go, okay, so it told me this one, it told me one, O-N-E, you can change that one, let me try it again. And as long as there's not too many different mistakes in there, you could go through one by one that way. But that's something I see a lot, because if you've got 20,000 lines and they all have a different value and one of them is a problem, that value counts kind of becomes difficult to use. But yeah, so that in the error handling of that, as you try to cast it, it'll tell you what value it was unable to change. It'll only tell you the first one, but you can find a hint that way if your value counts is too long.
Yeah, thanks for sharing that. Cool. All right. Thanks, Josh.
You're welcome.
Okay, so now let's go ahead and continue to look at our data types, make sure that they work. If I wanted to get just my data types, not the info, what would I use? I'm getting a little bit of time. I'm going to say data types. I'm actually just going to copy it and then we'll talk about it because I'm running a little bit slow. Cool. So let's say I just wanted to get my data types. And this is going to be something we're going to sort of build on how I start exploring my data. So I'm going to gather my data types. Cool. Got them right there. I'm not going to do this guy right now. Okay. So if I've got my data types, let's say that I wanted to get all of the data types that were objects, right? And especially when I start looking at cleaning my data and exploring it, this is a really simple trick I can do where I'm going to call this string calls. I'm going to say this is equal to data types. And I'm going to say where data types equals object. And what this is going to do is it's going to, if I just do str calls, this gets me just the columns that are of type object, right? That's just what I did. Cool. Now, if I get the index of this, because this is a series, if I get the index of this and I say str.calls.index, what this gives me is a list of the column names that are of object type, right? So if I wanted to view that, if I want to just see in my data frame all of the ones that were just an object, I could say SP or SB, sorry, of str.calls.index. And this will give me back only the ones that are of type object. Cool. But what I want to do is I actually want to iterate and I want to check to make sure all the values within this object are fine, right? And Josh has a great point of if you've got a super large data set, this might take a long time, but cleaning your data is going to take a while either way. It's like 80% of what you're going to be doing is cleaning data. So be prepared for that. But what I could do is I could look and I could say something like index, or let's say I'm going to call this, I'm going to redefine str calls is going to equal str calls index, and str calls just stands for string columns. Perfect. Now, if I wanted to iterate through all of these guys, right? If I wanted to view this and see, are there any issues within this? what I could do is I could say for call in str calls. I want to first print the column name. I'm gonna say call because we remember that's just iterating through the column name. Perfect. I'm also going to print the actual column values. So I'm gonna say SB of call, because remember in my for loop, this just represents date and then it, goes on and keeps going. Dot value counts. And I'm gonna say drop NA equals false, meaning I want to see if there's any missing values as well. And then lastly, just to give myself some space as I'm viewing this, I'm going to give a new line, which in Python is /n. So I'm gonna give 2 of those. And now if I run this, we're gonna see it gives me a lot of data, but it iterates through each of my string objects, and I can start looking and saying, are there any inconsistencies within my data? Right? I can look and say, all right, there's some different coaches. I can start at dates, going through the Super Bowl. Are there anything weird? Nope, that checks out. Anything weird here? Nope, that checks out. Anything with coach winner? Yeah, actually, I see a couple of these coaches have a underscore here. Okay, I know I'm going to need to handle that because Bill Parcells underscore, I'm going to assume is the same as Bill Parcells without the underscore. And I can continue to go through all of my data. So that's a quick trick, just to, instead of having to say, date.value counts or coach loser.value counts, by creating this for loop, now I can just sit and look through this. It's just a couple lines. I can sit and look through this and say, okay, is everything, is this data relevant and is it quality data? Any questions on what I just did there?
Scroll up a little higher to the code, please.
Yeah, of course. If you guys are following this code, you should be able to see it. But it's right there. Again, I created this index. This index is just a list of the column names that are my object type. I say str equals just that list. And then I'm iterating through that list where column represents each one, as it for loops. I show that first one is date. That's this guy. Then it prints all the value counts, and then it gives me a couple spaces there. Any questions?
So basically this, the for loop pretty much works for any data set. So basically you can pretty much get a summary of all the values contained within each column of the data set, correct?
Yeah, because I'm utilizing this index, and this index is just going to be the column names of my data frame. Yeah. So if I were to have said string, if this was num calls, but I mean, and this was type int 64, this technically would work. I would probably reserve this more for a string, just because it's a quick view. But if you got like, let's say you're taking a pulse and your data is just like each, every 3 seconds you're getting a numeric value, your value counts are going to be insane, and it's not going to. Josh is shaking his head like, yeah, it's going to be value counts usually is a little bit. I don't know, Josh, how you feel. Just knowing your column. If you got like value counts, yeah, it's more for categories. If you've got it like for how many Super Bowls a team has, like if there's some sort of data and you're like, oh, okay, the max is going to be 10. That's okay. Then that's fine. But if you're dealing with just a ton of different numbers, I would reserve value counts is reserved for categorical, meaning like string object values.
I gotcha. Thank you.
Yeah, because even like
And that's kind of what I was
here, like even with date, it's just sort of useless, right? Like, yes, this is technically a string, but this doesn't tell me anything. So go ahead, Josh.
I was just going to say that's what I was kind of trying to point out before. is some things just have too many unique values.
Mhm.
But-
Yeah. But by this, one thing I do want to show, that way we can address one more thing after this, is by looking at this, I see, okay, Coach Loser, I've got an underscore, and I think also with Coach Winner, we have the same thing, right? And so what I can do is now I need to go and clean up that data. So I'm just going to exit out of this. What I can do is I'm going to fix that column the same way I fixed my other column, right? Where I'm going to say SB of Coach Winner equals. Now, could I create a for loop if I had multiple ones with the same issue? Sure. I don't need to, but I totally could. Where it is going to be Coach Winner dot replace. Sorry, it's dot string because I'm dealing with a string. I say dot string dot replace. I'm going to pass in again. What do I want to replace? Which is this underscore, comma. What do I want to replace it with? Nothing. So I just give it empty strings. So now if I run this, cool. And then I say SB of Coach Winner dot value counts. We can see now all of those underscores have gone, and now Bill Parcells has more, right? It has 2 instead of the 1 and 1. Cool. You do the same thing with Loser, so I'm not going to do it, but it's the same exact thing.
Notice
Any
that this is notice that he's using str.replace, not just replace. Those are 2 different things.
Mhm.
Yeah. So string methods are cool.
Yeah, and there's a great little thing on string methods on the platform. Okay. Now the last thing I want to talk about, our column error, if I were to do SB of state, this isn't what I'm going to talk about, but if I do value counts. I see that I've got Florida is FL and I've got Florida up here. Right, so I'd want to replace those. So again, what I can do, I already have the code, so I'll just copy and paste it. Clean up my data. Is I want to here replace my state, Florida, Florida. Cool. And then now Florida has 15 versus the 14 because I assigned that FL to Florida. Great. Now, the last thing I want to talk about is missing data. This is really important. So I might go maybe 3-4 minutes over. So I want to look at my missing data. Missing values are really, really common, very problematic in our data. And there's one thing to note is there is no right way to handle missing data, right? There are different strategies you can do, but there's no definitive right way. And sometimes it takes, a judgment call. And when you guys make a judgment call, just make a comment of why you made that judgment call. Here's what I was thinking. Here's what I did. Here's why I did that, and support that, right? And so that helps. And oftentimes, you will have multiple sort of versions of handling data in a certain way to where you're not going to have it just, okay, I just dropped this column because, or I just dropped these rows because that's what I'm thinking. Say, okay, well, how does it affect it if I drop these values? Well, what if I actually impute these values instead? How is that change? If I'm dealing with a model, how is that performance? Is it better? Is it worse? So just know that there's no definitive one. You don't have to pick one. You might try one way where you drop data and then you're like, actually, I didn't like this. Gave me a negative. I didn't like where that ended up. So now I'm going to try a different strategy. And that's very, very common. When we're dealing with data, if there's not, if they are missing, if data is missing completely at random, so the fastest and easiest solution is to drop the rows with the missing values. But I want to really reiterate this is data is valuable. We want to keep as much data as we can. And so we don't always just want to drop rows or drop values. We want to see if we can impute meaning, create a value there or replace it with a mean or a mode or a median, something of that nature. So we can drop values. And I think even in Josh's data cleaning, he says that anything that is 2% or less, right, Josh? Anything that's 2%, that's kind of your cutoff. If you're trying to drop more than 2% of your data, do something different. So there's a couple
Good
different
rule of
ways that you
thumb.
can handle it. Good rule of
But
thumb.
like you
Yeah.
said, it's always going to be a judgment call. It's always going to be, subject matter dependent, explore your data. It's never one easy answer. And it always makes a big difference.
Yeah.
So
There's a great piece on the platform
Josh.
about missing data. Learning goals. Go ahead, Adam.
But doesn't that go back to your comment earlier that sometimes it pays to duplicate the data frame so that if you drop something and it doesn't work, you don't have to rerun, that you're working on something? I think
Yeah.
that's a good point that you made earlier.
keep that. So you might keep a pristine version of that SB where you haven't done all these changes and then start making changes on a new version, just so you can revert. It's easy to revert.
Yeah, that's often very helpful.
Yeah.
In my projects, I often have half a dozen different versions of the data that I'm testing with different things.
Yeah, so there's a great breakdown on the platform here with this identify and handling missing values. But in just looking at this, we've got a couple missing values that we can deal with. We saw that, well, we visually saw it, but if I want to just check, right, if I'm just seeing, is there any sort of missing values? I can say sb.isNA. .sum. And it's going to go through and it's going to tell me the places in the columns where there is missing values and how much, right? So it looks like in my referee, my umpire, my headlinesman, my line judge, my field judge, my back judge, my side judge, it looks like all of those are missing. So I could go explore this, right? We don't quite have the time. But what I'd want to do is go say, okay, well, what do these have in common? Are these, I can tell you just from a little bit of info because I know this data. If I say sb.info, not info, sorry, I meant head. If I look at this, I sort of see it's the first couple Super Bowls, right? Like the first ever one in 67, 68, 69, 70, didn't have back judges, didn't have referees. So I can kind of say, okay, maybe they didn't, maybe I look up and say like, I mean, did they even have referees back then? Was there not necessarily data or was there not necessarily like all these different names? What is the reason there? Josh has a great point. Yeah, it's because I know the data. So that's why I can sort of jump to this. But I'd want to make sure and investigate which rows have missing values and what do they have in common. So that way that drives my decision, not just me randomly imputing or me randomly replacing the value with like missing. Okay. Makes sense. Any questions on that? Okay. So I see there's a couple things I can do. I can drop this data, right? I can drop, it's not very many. It's like 4 out of 50 something, which I guess is almost 10%. So I probably, I don't want to drop it. Also because I recognize there's some commonality at the beginning of this where, hey, it's sort of the first ever Super Bowls. I think that's some important data to know if I ever want to say who's the first, I just think that because there's only 53 or 50 some odd rows, I want to keep this data. And so I can either impute that data or I can sort of fill it with something else. What I would do if I'm looking at this data, and Josh and Adam, I'd love to see your opinions, is I would actually just fill this in with a value of missing, right? Where I want to sit and say, okay, I want to fill in just this piece of missing. I still keep all of this really valuable information here, but because it's all similar, it's just dealing with my referees, I'm going to fill that in with missing. So what I can do is I can say null values. So I'm going to create a variable called null values. null vals. And that's going to be equal to my SB dot is NA dot sum. Perfect. So I've got that. What is that? Squiggly there. Cool. So now what I want to do is I'm going to create a variable. I'm just going to call it X just for time's sake. And I'm going to say null vals. So I'm getting that value. Then I want to get just the ones that are greater than 0. So I'm going to say null vals greater than 0. Then I want just the index. I just want the columns or the, if I look at X, let's see what X looks like. Oop, that's a mess. I see, okay, it's these columns that just have some null values greater than 0, right? And I've already seen that, but this is a great thing just to make sure that I didn't miss anything, right? If you've got a lot of columns, it's a great thing to make sure you didn't miss anything. So I've got my index, perfect. So what I can actually do is I'm going to, instead of going in and saying, and identifying each specific column and saying replace the missing with 0, what I'm going to do is I'm going to say def fill missing. And within that, I'm going to say for num for miss, sorry. And X is just this guy. Remember, it's this index right here. Just like we did with our string calls. But what do I want to do? I want to say SB of miss. So I'm just saying that specific column, I want to fill NA. I want to fill it with missing. And then I'm going to say in place equals true. Now what this is going to do is here's my index. It's going to say SB of referee. It's going to fill all of the missing values with the word missing. And then it's going to do that in place equals true. It's going to then go to umpire, go to SB of the column umpire. It's going to run this fill in A. If I just had one, I could say fill in A. I could just say the actual column name fill in A, but this is a for loop that allows me to do that. Then I can, so I run this. I now have my function. I got to run my function. So I can say fill missing. Cool. It runs it. And then now if I go back up, I'll just come back here and say SB, let's check dot is NA dot sum. And now I have no missing values. And if I say SB dot head, now you just see that I inputted and changed this data just to missing. So now I still get to keep all this good data, especially because it's the 1st through 4th and 5th Super Bowl. But then now this is just filled in with missing versus being a null value. Any questions on what I just did there? I know we went 8 minutes over, so sorry about that. But any questions? I moved a little bit
What a
quick.
pleasure to use the function. When I went through this, we weren't doing that, so it was tedious. We went column by column.
Yeah, when I was writing
can-
this today, I was like, oh, I'll just go to function. That's way easier.
If you're gonna fill all of the missing values in the data frame the same way, there's actually a data frame.fill NA. You can just do fill NA, SB.fill NA. So usually you're not gonna use the same strategy for every column.
Right.
Yeah.
Usually you're gonna do different columns, different strategies, but you don't actually need the loop. You could just do SB.fill NA missing, and it would fill in all of the missing.
Something like this is what he's saying.
We still need the in place modifier to be true, correct? On the fill in NA.
Only if you wanted to actually change it. So yes,
Okay,
Yes.
I just wanted to make sure.
yeah. So that would work. That code would work too. I just tested it. Yeah, there's very few circumstances where you're just going to say all the missing data in every single column in the entire data frame I want to fill with the same thing.
Sure.
But you could.
This just happened to be one of those circumstances.
Yeah. Yeah, and you can, this is, and throwing this is similar to if I had some sort of index, if I did have a condition that created an index, this is a way that you could, right? If, let's say that there was, again, when we looked at this X, if there was some random one that I didn't need, I could create an index with that, or even just create a list and then walk through and run this. But Josh is 100% right. Because I'm doing everything, all of my missing values are going to be called missing. You can just run this guy right here. Okay, that's all I've got for class. I'm going to stop for answers. I do want to say that if you guys if you guys have this, there are some questions that, is just good practice for filtering, for utilizing this. And I believe there's a group by on there as well. So these are some extra questions if you wanted to. We can, for the next 20 minutes in our breakout rooms or in our office hours, we can go through these, or you can do these on your own as well. So that's all I got. Are there any questions before I stop the recording?
I would say what I did last time is that
Yeah.
this is so important to learn and get comfortable with, because no matter what you're doing in this, what stack you're in or what week you're in, everything starts with this. This is the one solid piece that doesn't change no matter what we're doing. So the more comfortable you become with this, and like Will said, it's the most time consuming, but this is the standard for everything we're going to do, machine learning, advanced machine learning. So it's really important to understand this stuff and get it down good, get it down well.
And real life data is going to have a lot of missing data, a ton. And like some especially like sociology stuff, it might be 80–90% missing for the whole data frame. So this is something you're learning how to deal with missing data, especially. It's an art that you're going to use a lot.
Perfect. Any other questions on what we just shared today? And then we'll go into the additional stuff. Any questions?
That was a great class. I just want to say that.
Oh,
Excellent.
thanks.
Yeah, I'm on my phone
you
the
enjoy
whole
it?
time, but it was great.
Yeah, that's awesome. Thanks, everyone. I appreciate that.
No problem.
Ashley wanted to ask about using the thresh argument for.
Yeah, I think that's something we can talk about
okay,
in
okay.
office hours. Yeah.
Cool. Oh, I thought
Any
we
other
were not.
questions? Not quite. We're just finishing up class. Any other questions, friends?
Everybody have a good evening.
Yeah, you too, boss. Okay, I will stop the recording.